Hello, calculus fans. All right, so let's let R be the region bounded by y equals sine x, y equals 1, and the y-axis. This region is revolved about the x-axis to generate a solid. Let's find the volume of this solid. I think the first thing to do is to take a look at the picture of this region. So there's y equals sine x, y equals 1, and the y-axis bounding this region. We're going to revolve this about the x-axis. Notice that I've sliced it. That slice is going to get revolved. But this time when we slice the solid, that slice is not a disk anymore. It's a disk with a hole in it. It looks like this. You have a disk and you cut a disk out from the middle and you get a washer. You have an outer radius and an inner radius to measure a washer. So since a washer is just a big disk with a smaller disk cut out, we get a nice formula for the volume of a washer. So delta V is the pi times the outer radius squared minus pi times the inner radius squared. And that gives you the area of the face of the washer, because you're just taking a big circle and subtracting off a little circle. And then you have to multiply by the thickness. So we're going to write this as pi times big R squared minus little r squared times thickness. So I'm going to use R for outer radius and little r for the inner radius. I want to go back to the picture, but this time with the radii labeled. Okay, so there's an outer radius and an inner radius. And the inner radius, it depends on where the slice is. As we move to the right, that inner radius is going to get bigger. So the outer radius is always 1, no matter where the slice is. But the inner radius is sine x. It's the distance from the curve to the horizontal axis. That inner radius will change depending on what x is. So delta V equals pi times 1 squared minus sine squared x times delta x. So that's outer radius squared minus inner radius squared times pi times the thickness. And we can see that there's an intersection point on the right that happens at pi over 2. That's because sine of pi over 2 is equal to 1. All right, we're ready to calculate the volume. So V is equal to the integral from 0 to pi over 2 of pi times 1 minus sine squared x dx. 1 minus sine squared x is just cosine squared x. And then we have to use a half angle formula. Remember that when we want to anti-differentiate an even power of sine and cosine, we have to use half angle formulas. Okay, I'll just pull the pi over 2 out. That's no big deal. And then it's not too hard to write down an antiderivative of 1 plus cosine of 2x. You should get x plus 1/2 sine of 2x. And this is evaluated from 0 to pi over 2. So that's pi squared over 4. That's what you get when you plug everything in, because if you put in 0, you'll get nothing. If you plug in pi over 2, you'll get nothing when you plug it into the sign, because you end up with sine of pi. Now, this particular calculation gives us a new method. It gives us the washer method. So we have to have an outer radius and an inner radius to compute things with the washer method. Okay, that's all for now.